I'm going to show you how I installed a Bluetooth audio system into a Schuberth C5. This is a really nice helmet. It's my second Schuberth. I spent a lot of money on it, but I really didn't want to spend another several $100s just to be able to hear my GPS. I wasn't interested in talking on the phone or talking to a group of other riders. All I really wanted to do was listen to hear my turns on my GPS. So this is what I did, and it cost about $30 and it works great. The first rule that I followed was to do no harm to the helmet. Again, this is a good helmet, it's an expensive helmet, and I value my brain, so I didn't want to do anything that would interfere with the shell of the helmet. All of this work is external and in no way affected the shell or the safety of the helmet. So the first thing I did is I popped off the factory cover, which reveals the cavity for third-party communication devices. And I noted right away that this was going to be a little more challenging. I was hoping to find wires that I could splice into, but instead there were seven gold plated pads that the third-party units obviously connect to. So my solution was to get a proto board from an electronics shop and cut it down to the size that's shown in the lower part of this photo. I needed to get 4 positions that would connect to those 4 gold pads in the helmet. And you can see what I had to do is just cut off some of it's easy to cut material. It's kind of like a phenolic material. It was easy to cut, and I had to cut a couple notches that went around some internal plastic pieces in that cavity for the communications device. And I had to drill a couple holes to mount some screws in that same plastic. And then I had 4 centrally located and carefully aligned, I should say, pins or ports that I will show you how I use those to connect to the helmet pads. These things are called header pins. I use these that I happen to have. You just snap off the number that you need. They're very inexpensive. They also come in right angle form, which would have been even easier, but not necessary for this project because they're easy to bend. So here's that little piece of proto board that's been drilled and notched and all the excess trimmed away. And then I put the header pins through the board and soldered them. Here the excess pins have been trimmed short as possible. And the next step is to solder in 4 pogo pins. The pogo pin is that little gold pin on the right side of the slide. And if you look closely, there's a little pogo stick type thing that comes out, and it's spring loaded. So those pogo pins will be facing down. And because they're spring loaded, when this assembly is screwed into the helmet, the pins will push up against those gold pads that in the same manner that the third-party communications devices attach. I was able to get these pogo pins from DigiKey. And here's a picture of that assembly after the pogo pins have been soldered in. It's really important to use a very small amount of solder on the pins because extra solder fouls the pin action. And here's the bottom side of that same assembly, and you can see the pogo pin sticking down. That's a spring-loaded portion. So this side of the assembly will face the inside of the helmet. All that's left to do with this part is to screw it into the helmet, and contacts to those 4 pads, which by the way are numbers 3, 4, 5, and 6. Those are the speaker input pads. So 3 and 4 go to one side, 5 and 6 go to the other side. Here's another shot of the bottom surface of that assembly, so you can see those pogo pins really clearly in this picture. And this is what it looks like once it's screwed into the helmet. So at this point, the only thing left is to attach a Bluetooth device. I went to Walmart and I spent big, like 10 or $11 on this Groove-On wireless earphone setup. I liked it because it has rubberized covering over it, which makes it fairly water resistant. And it also has large buttons. The downside is it has 7 hours of playtime, but it does recharge quickly with a USB port. And my thought was, if it doesn't work out, it should be straightforward to peel it off and put a different one on. This next step was surprisingly hard. I'm glad I practiced with the remnants of wire. First step is to cut off the earbuds so that the tails going to the control are about 2.5 inches long. Then I slit the two halves of the wire with some scissors and stripped off the insulation. And I was really surprised to find this. I don't know what it was, sort of a plastic film slash filament around the outside of these wires. I don't know what it's for, but anyway, it definitely interferes with soldering and crimping and making a good connection. So this is how I got rid of it. I found that if I used a lighter and just briefly flashed the wires twice and then gave them a very light sanding with 300 weight sandpaper, they were able to accept solder really well. And on the right, you can see where they're nicely tinned. I didn't want any failures, so in addition to just crimping these wires to the plug, I also soldered them. And here you can see it starting to come together. The Bluetooth device is on the outside of that factory cover panel. I drilled a couple holes to put the wires through the panel. And then the soldered and crimped terminals are put into a standard 4 conductor plug that fits the headers on the proto board. I then used a little bit of this foam tack glue to seal the holes and to attach the um, Bluetooth device to the outside of the plastic cover. It's good glue because it does harden up pretty well, but it remains slightly flexible. And I figured fumbling around with my gloves, pushing those buttons, I didn't want something that was too rigid. I think this will give, and it seems to hold it really well. And voila, the plug goes into the proto board, the cover snaps back into place, and it's done. So for under $30, my helmet is Bluetooth ready. I can bind it to my cell phone or my GPS unit, and it works really well for this purpose. Thanks for watching, and happy riding.